We'd like to discuss the integration by substitution in this second part of this topic. We have discussed this in the first part, and now in the second part also I'm going to give more examples about integration by substitution. Let's start with this example. Evaluate. Number one, the integration of x divided by square root of x plus 1 dx. And I want to integrate this function. And as you see, it is not easy to find the integration if it is in this form, so we need to simplify it. I want to write it in a form so that can be easily integrated. And that's why we need to use what's called that integration by substitution. For the integration by substitution, I will choose part of the function to be u. So I will say let u equal to what is inside the square root, x plus 1. Now, differentiate, I will have du equal to dx, 1 dx. So du equal to 1 dx. Now, my integration will be x divided by square root of u multiplied by dx. Dx is equal to du. But you can see now, still I have x in the integration. And this shouldn't be there. After we substitute x plus 1 by u, I shouldn't have any x. Now I need to write x as a function of u. From the substitution, I have u equal to x plus 1. So x will be u minus 1. So this one can be written as u to power minus 1/2. I will write the square root up with negative power multiplied by x. X is u minus 1 du. Now you can see all the variables now are u. I don't have any x. Now open the bracket. I will have u to power minus half multiplied by u to power 1 will be u to power 1 over 2. If we add the power, minus u to power minus 1/2 du. Now integrate, and as you know, integration means add 1 to the power. So 1/2 plus 1 is equal to u to power 3 over 2 divided by the power 3 over 2 minus 1/2 plus 1 is u to power 1/2 divided by 1/2 plus constant c, because this is indefinite. Now write it back. U is equal to x plus 1. So this one, the denominator, since it is a fraction, it will be written as, or upside down, 2 over 3. U is equal to x plus 1 to power 3 over 2 minus 2 multiplied by u is again x plus 1 to power 1/2 plus constant c. So this is the integration of x divided by square root of x plus 1. We used integration by substitution to make it easier to find. Let's take another example. Number 2. Let's find the integration of cosine to power 3x multiplied by sine x dx. For the integration by substitution, we usually look for the given function. If I have one function is a derivative of the second one, then I will take the original function will be my u substitution. And you can see, for example, in this one, I have cosine and I have sine. Cosine x and I have sine. Cosine, if we differentiate, I will have minus sine, which is there, I have it there. Now for the sine, if we differentiate, I will get cosine x. Now I need to choose one of these two functions to be u substitution. So which one of them? Usually we are looking for the function with the power to be the substituted one. Okay? We are substituting the function with the power. So I'm going to use cosine in this case. I will say let u to be cosine x. This will give me du is equal to, if we differentiate, I will have minus sine x dx. From this one, I will find dx. dx is equal to du divided by minus sine x. Let's use this substitution or this equality. Now my integration will be cosine is u to power 3 multiplied by sine x multiplied by dx. I'm going to replace it by du divided by minus sine x. Now simplify. Sine x will cancel sine x. So I'm going to have minus outside u to power 3 du, which is equal to minus. For the integration, we said that we add 1 to the power. So this one will give me u to power 4 divided by 4, or I can plus the constancy, or I can write it as minus 1 over 4. Now u to power 4, u is equal to cosine, so this is cosine to power 4 x plus the constant c, and that's it. So it is minus 1 over 4 cosine to power 4 plus the constant c. This is the integration of cosine to power 3 multiplied by sine x dx. Let's take another one. Number 3. Or let's find the integration of tangent square, or let's say tangent of 2x plus cotangent of 2x all to power 2 dx. I want to integrate tangent 2x plus cotangent 2x all to power 2. You know from the identities we have a plus b square is equal to a square plus 2 ab plus b square. So I'm going to use this identity to open the brackets here. So I will have integration of tangent square of 2x, square root of the first one, plus 2 multiplied by tangent 2x multiplied by cotangent 2x plus cotangent square of 2x dx. We know that the tangent and cotangent, they are the multiplicative inverses of each other. Tangent is equal to 1 over cotangent, or cotangent is equal to 1 over tangent. We know that the tangent is equal to 1 over cotangent, which means if we multiply these together, I will get 1. So the integration will be tangent square 2x plus 2 multiplied by tangent multiplied by cotangent is equal to 1. So this is 1 only. Plus cotangent square 2x dx. Now I have three terms. I have tan square plus 2 plus cotangent square dx. We know that tangent square, I don't have direct function, so that when I differentiate, I will get tan square. So in this case, I will use some of the identities. We know that tangent square of 2x is equal to secant square minus 1. Also, cotangent square is the same. Cosine square 2x is equal to cosecant square 2x minus 1. So I'm going to use these identities to simplify the function I have. So the function now will be, or the integration will be written as tangent square is equal to secant square of 2x minus 1 plus 2 plus cotangent square is cosecant square 2x minus 1 dx. And you can see I have minus 1 plus 2 minus 1 will cancel each other. So all what I have now is equal to integration of tangent square, or I'm sorry, secant square 2x plus cosecant square 2x dx. Now by the substitution, let me choose this one to be, I will say let u equal to 2x. So this will give me du is equal to 2 dx, or dx will be written as du divided by 2. So I will have now integration of secant square of u plus cosecant square of u multiplied by dx, which is du divided by 2. I will take 2 outside, will be as 1 over 2. Now the integration of secant square, just looking for the function when we differentiate, I will use secant square, and that's it. That will be tangent. So this is tan of u plus, or sorry, the integration of cosecant is minus cotangent plus constant c, because this is indefinite integral. Right, u back, I will have 1 over 2 multiplied by tangent of 2x minus cotangent of 2x plus the constant c, and that will be my integration now. It is 1/2 tangent 2x minus cotangent 2x plus the constant c. So this is the idea of integration by substitution, just to simplify the integration to find the integration. Let's take one more. Number 4. See what is the integration of e to power ln of x multiplied by 1 over x dx. E to power ln x multiplied by 1 over x. Or no, let me change this one. This is going to be very easy one. Let me use secant x multiplied by secant x tangent x dx. Integration of e to power secant multiplied by secant x multiplied by tangent of x multiplied by dx or dx. Now to find the integration of this one, let's try to find some relation between the function given there. What is the relation between secant x and secant tangent of x? We have a relation there. You know that the derivative of the secant is equal to secant multiplied by the tangent. So I'm going to choose secant to be my u substitution. I will say let u equal to secant of x. This will give me, if we differentiate, I will have du equal to secant x multiplied by tangent of x dx, or dx equal to du divided by secant x multiplied by tangent. So the integration now will be e to power u multiplied by secant x tangent of x dx is du divided by secant x times tangent of x. Now simplify. This secant will cancel this secant tangent with tangent. I will have e to power u. So the integration is integration of e to power u du, which is equal to e to power u plus the constant c. Or this is equal to e to power secant of x plus the constant c. So this is the integration by substitution. This was number 4. Let's take one more, that will be number 5. What is the integration of tangent x divided by 1 plus ln of cosine x, or just cosine? Dx. Tangent divided by 1 plus ln cosine of x. I need to find the integration for this function. And you can see this is not easy. I don't have direct function, so that means I differentiate, I will get tangent divided by 1 plus ln cosine x. So all what I will do now, I will use the integration by substitution. Integration by substitution. As we did before, I will let u equal to, usually we are looking for the most complicated part, so that makes the integration easier. So if we choose u, it will be 1 plus ln cosine x. Now if we differentiate, du will be integration of ln is 1 over cosine will be down, the derivative will be of sine is up, so it is minus sine dx, or this is equal to minus tangent. So du is equal to minus tangent x dx, and dx will be written as du divided by minus tangent x. So now my integration is tangent of x divided by u multiplied by dx. Dx is du divided by minus tangent of x. Now simplify. I will cancel tangent with tangent. This will give me minus integration of 1 over u du. So it is minus 1 over u du, which is equal to, this is from the rule of the logarithmic, this is equal to ln of u plus the constant c, or it is minus ln, write the u again back, it will be 1 plus ln of cosine of x plus the constant c. So this is the integration of tangent divided by 1 plus ln cosine x. One more problem. will be number 6. What is the integration of x plus 1 multiplied by sine x square plus 2x plus 3 dx? We know the integration of sine x dx is equal to minus cosine, sorry. So if we can write this function in this form, that will be great. I have x plus 1 multiplied by sine x squared plus 2x plus 3. I can see there is some relation between this part and this part. There is some relation. You can see it somehow, it is the derivative of what is inside of the sine function. X squared plus 2x plus 3. So let's try to choose what is in the angle. Let u to be the angle of the trigonometric function, x squared plus 2x plus 3. This will give me du, if we differentiate, is equal to 2x plus 2 dx, or dx can be written as du divided by, if I take 2 as a common factor, it will be x plus 1. I took 2 as a common factor. So the integration now is equal to x plus 1 multiplied by sine of u multiplied by dx. Dx is du divided by 2 multiplied by x plus 1. Now can you simplify it? I will cancel x plus 1 with x plus 1. Yes, we can simplify it. So I will have 1 over 2 outside, integration of sine of u du, which is equal to, the integration of sine is minus, so minus 1/2 cosine of u plus the constant c. Write it back, I will have minus 1/2 cosine of u was x squared plus 2x, I think plus 3, yes, plus 3, plus the constant c. So this is the integration of x plus 1 multiplied by sine of x squared plus 2x plus 3 dx. As you can see, what we did, we used the integration by substitution to make the integration easier to find, and we did it. So we made the integration easier, and we found the integration of the given function.